Hey everybody, we've got a friction problem with the guy standing on a ladder. The given information is that the ladder and the person weigh 30 pound and 100 pound respectively, and the center of mass of the 12-foot ladder is at the midpoint. This angle is 30 degrees, and we're saying that there's no friction about point A, which is the ladder against the wall. So they're giving us again that x is 4 feet and theta is 30 degrees. They're asking us to find the magnitude of the friction force exerted on the ladder by the floor. And they're also asking us what the minimum coefficient of static friction between the ladder and the floor, which is necessary for this guy not to slip, or for the ladder not to slip and this guy to fall. So here I kind of already drew the ladder. We have 30 degrees and it's a 12-foot ladder. So other things that we need to draw on our free body diagram would be the weight of the ladder, which is sitting at the center of mass. And then we have the weight of the guy, so 180 pounds and 30 pounds. And if I'm going to draw down like this, we know that this is 4 feet. We're going to have to compute this distance here. Try that a little better. We're going to have to solve for that distance. We're going to call it x1. And let's go ahead and draw our forces on here. So we know that we're going to have our normal at B. And which way do you think friction is going to be going? Is it going to be going away from the wall, from this wall? Is it going to be going this way, or is it going to be going towards the wall? Well, the ladder's wanting to slide out, so the friction is helping hold it up. So the friction is going to be going to the right. Now, since we only have the ladder sitting against the wall, all we have is the normal at A. No friction there. So we're also going to need to compute this distance as well. We'll call this H1. So x1, if we think about it, we said that the center of mass of the ladder is sitting halfway through. Well, if this is 12 feet, this has got to be sitting 6 feet away. We know that this is also 30 degrees. So when we're looking at this, this is our opposite side, and we have our hypotenuse. So x1 is going to be the sine of 30 degrees times 6 feet. And h1 is going to be, now we're going to look talking about this length right here, so it's going to be cosine of 30, and it's the entire length of the ladder, so that's going to be 12 feet. So if we put those into our calculator really quick, we know that this is going to be so we got cosine of 30 times 12, that's going to be 10.39 feet, and this should be 3 feet. So now let's use our equilibrium equations to compute FB, NB, and NA. What we're trying to solve for here is our friction and our normal. So if I sum my forces in the x direction, I'm going to have the friction at B minus the normal at A. So we know that once we find either the friction at B or the normal at A, we'll have the other one. So we'll be able easy to solve for NA if we sum our moment about point B, which we'll do here in a second. If I sum my forces in the Y, I'm going to have NB, which is going up, and then I have these two forces, negative 80, 180 pounds, and negative 30 pounds. So my normal at B is equal to 210 pounds. Now if I sum my moment about point A, we're going to have this 30 pounds, so it's going to be rotating clockwise, so it's negative, times we computed x1 to be 3 feet. And we've got this 180 pounds, which is also going to be going clockwise, and that distance was given at 4 feet. And then we have this normal at A rotating clockwise, so that's going to be normal at A times the height of 1, which we computed to be 10.39 feet. So let's go ahead and solve. And let's plug this into our calculator, see if I got this right. So 33 is going to be 90, negative 90. Say 33 times negative 90 and 184 times. So we're going to have a negative 810. Take that to the other side and divide it by 10.39. And I get 77, or we'll call it 78 pounds. So once I did this, once I have this, I can look at this and say, well, FB is also 78 pounds. So now I have FB. I also need to calculate NB, which I've already done here. So I have that the solution for A is NB is 210 pounds, and the friction at B is 78 pounds. Now we've got to find the maximum coefficient of the static friction between the ladder and the floor that is necessary for the person to be able to climb up top without it slipping. So if I draw the other free body diagram, now I have the only thing that changes here is now the weight of the guy is 180 pounds. So this x distance is going to change, and how's that going to change? Well, now it's going to be the sine of 30 times 12. Which we know is going to be 6 feet. We've already computed this, H1, which came out to be 10.39 feet. So when we're solving for part B, we do the same thing. We're going to sum our forces in the x, going to sum our forces in the y, and again I'm going to sum my moment about point B. Again, this is point B, this is point A. Our forces do not change, so our friction and our normal, those stay the same, and also our normal at A. So summing my forces in the x, again I get that friction at B is equal to normal at A. Sum my forces in the y, I'm going to get the same thing, that is 210 pounds. Just like we did over here, nothing changes in the y direction. Now what changes is our summing our moment at point B. Now we're going to have 30 pounds. 30 pounds times, that's going to be 3 feet. That's this x1 distance that we solved for earlier. It's the same distance. And that's going to be negative minus this 180 pounds, because it's also going to be wanting to rotate clockwise, times, and now we computed this new x distance, which is going to be 6 feet. And then I'm going to have plus my normal at A times 10.39 feet. So by doing all this, I get my normal at A is 112.6 pounds. Now once I have the normal at A, I can plug that in for my friction at B, and we know that friction is static friction is equal to the coefficient of static friction times its normal force. So here we're going to have friction at B is equal to static friction at B times the normal at B. So we're trying to find the coefficient of friction, so that's going to look like the friction of B over normal at B. So our friction at B is the same, so friction at B is the same as the normal, so that's going to be 112.56 pounds. So 112.6 pounds divided by the normal at B, which was 210 pounds. So the minimum coefficient of static friction would be 0.54. Now what does this mean? Well, if it was greater than this, it's going to start to slip. So I hope this helps. Keep an eye out for additional videos. Thank you.